So how many of you guys have been to a restaurant and took one look at the menu and not have had a clue of what anything means? Like, look at this for example. Smoked salmon tucked in a 2-egg omelet with a lick of Tasmanian wasabi mustard and topped with some tobiko and bonito flakes. Like, I don't even know how to pronounce half of those things. How am I supposed to know what that means, right? And if you look at all the other items on this menu as well, like, I don't know what any of them means. And for me, I'm a particularly picky eater, so I'll usually only understand like 1 or 2 of the items on a specific menu and then only order those items, right? So if you don't know how to pronounce half of the words or what they even mean, how are you going to order that item? And you're not going to know what it looks like, right? So this problem can actually be solved with augmented reality. And AR is basically superimposing a virtual object on top of your view of the real world. So with menus and with food, what we can do is take a 3D model of what the food looks like and create an app or something and actually have that food or that menu into the app, and when you tap those food items, you can actually see what that food looks like in real time through your phone with an actual app. So alongside AR, there's another technology called virtual reality, which is basically an entire simulation. So it's an entire virtual world. So the difference between virtual reality and augmented reality is the fact that with VR, it's an entire virtual world. But with AR, you're just adding objects to enhance your actual world. So there are 4 main types of AR. It ranges from really simple AR to pretty complex AR. So marker-based AR is the most simple type of AR, and it uses a QR code or some type of 2D code to scan it and then produce an object. So in this example over here, we can see the marker, which is the square with the triangle inside it. And what happens is once the camera detects that marker is there, it calculates the distance to that marker in order to be able to place the object correctly. So you can see the camera has detected the marker and then placed the house on top of that marker. The next type of AR is markerless AR. It's also called location or position-based AR. And what this is it uses some type of sensor to be able to calculate your location. So over here in this app, we can see that the app has obviously calculated where you are, what your location is, and it's produced the specific restaurants or coffee shops, wash shop. It shows you what those buildings are. Another type of AR is projection-based AR, and what this is it projects images onto a certain surface, and then when you've touched something, it executes a different action. So over here, we can see that something has projected this screen onto this white platform, and then once the person has touched that, something else will happen. And how this works is it basically senses how flat the projection should be. So if someone wasn't touching it, it would be completely flat. But if someone is touching it, they can tell the bump between it. So you can see there's a bump. It's not a completely flat surface anymore. So they can tell that that person has touched that specific area, and then it executes that command. So the last type of AR is the most complex type of AR. It's called superimposition-based AR, and this is basically adding objects to enhance your world. So over here, this is actually IKEA's furniture app. And what that does is it basically allows you to place furniture in your home before you actually buy the furniture, so you can see what it looks like in your home. So this is superimposition-based AR because you can see the person's house is plain, there's no couch on it, and then you can see once they've added the couch, it's added to their view of the real world. And object detection plays a key role in this type of AR, because if you're not able to detect flat surfaces or specific objects, you can't place these AR objects correctly. So it's really important to be able to detect certain objects correctly, which is part of AI. So in addition to the types of AR devices, there are also certain components that all AR devices need to have in order to be able to execute AR capabilities. So sensors and cameras are probably the most important part of AR, because without a camera, you can't actually detect your view of the real world. And actually one feature that a lot of AR apps have is called depth tracking. And what that is if we go back to the IKEA example, let's say I want to place a couch, and if I place it right here, it's obviously going to appear bigger than if I place it all the way back there. So what depth tracking is it basically senses how far or close you're placing an object, and then it resizes that object according to that. So AR devices are kind of like mini computers. So AR headsets are, obviously phones are mini computers, but AR headsets are also mini computers. And they have a bunch of components of that actual computers have. So like CPUs, GPUs, GPS, and pretty much anything in order to be able to tell their orientation and location. So AR headsets also have mini projectors on them. And the reason for this is because they actually need to be able to project the AR objects into the space or into your real view of the world. And some AR devices actually have mirrors in order to guide your eyes to view objects correctly and in the correct orientation and where they are in space. So there are two main, platforms that we use AR on mobile, so on our phones and also on AR headsets. So with mobile AR, ARKit and ARCore are basically platforms that allow you to develop AR apps. So ARKit is Apple's framework and ARCore is Android's framework. AR headsets are also used to project, to have AR capabilities. So the HoloLens is actually a mixed reality headset, and what that means is the difference between AR and mixed reality, or MR, is the fact that AR is adding objects to enhance your view of the world, but mixed reality is combining a virtual world with your view of the real world. So it's a little bit different, but it's kind of the same thing, but it's a little bit different. And then the Meta 2 is an AR headset, and the Magic Leap is coming out later this year. Something that I think is really cool is AR contact lenses, and these are actually also called smart contact lenses, and a couple of companies are developing them right now, like Samsung and Sony, and right now what they're developing them to be able to do is take pictures and record video, which is super cool because you wouldn't need any phone or any device to take a picture. You could just blink your eye and take a picture or record a video, which is really amazing. And then the next step of that would be adding AR to the contact lenses. So right now we have to use our phones or AR headsets to be able to view things in AR, but if we could just put contacts in, it would actually feel way more immersive because we don't have to have any barrier device in order to be viewing AR. So this is an AR app that I built, and what it does is it basically, once you tap your screen, it shoots the eggs or the targets. It's a pretty simple AR app, but it kind of shows the basics of AR. So like placing a virtual object in a world, in your real world, and also like how objects interact with each other. So like the physics of like what happens when one object hits another object. Does it go through it? Does it collide with it? What happens? And then this is another app I created, which is similar to IKEA's furniture app. So it allows you to place objects down in your world. And obviously, the furniture is not very realistic. They're just some models that I whipped up really quickly. But you can see the cup, and I can resize it when I pinch my finger like this. And yeah, so obviously they're not realistic models, but you can see the table here. Yeah, so right now, even when I'm walking away from it, so you can't see any of the objects, but then I turn back and they're all still there. So, yeah. So, obviously, one main application of AR is in gaming, but there are also a lot of other really cool applications. So in e-commerce, kind of like the IKEA app, you would be able to place furniture in your real world, but also we can actually use AR to try on clothes in like just before you buy them, right? So when you're at a shop, you have to go in the change room and try on all these clothes, but we can actually use AR to see how these clothes would look before you actually buy them. In healthcare, we can actually use AR to model what certain parts of your body looks like. So there are actually some companies that are being able to model like specific organs and different parts of your body in AR. So you can actually use this for medical education to be able to interact and help students learn with these 3D, versions of our body. And one company is actually working on creating a realistic representation of tumors in AR. So for doctors, you can actually use this to be able to view tumors inside a person's body and be able to examine these tumors better and be able to kind of make connections as to how they're growing and what's happening. There's another application of AR in architecture, so we can actually see what buildings would look like before we actually build them. So we can put an AR building in the physical space of where a building is actually supposed to be built and then see what that building looks like, and as well as the interior design of that building. So the reason that I'm so excited for AR is because the technology is just building up now, right? And if we combine it with other exponential technologies like brain-computer interfaces, for example, this is going to completely change the way we view the world. Thanks.